So my name is Maoz Barkai. I'm the 3D Expert Product Management Team Leader at 3D Systems. And 3D Expert, for those who may not know, is an additive manufacturing print preparation software. And this presentation is about how to simplify your workflow with an integrated software solution. Okay, how do I minimize this? Oh, good. Okay, sorry. So what are we looking for in an AM software solution? First of all, save time, shorten design to manufacturing lead time. Second of all, save money, minimize cost of the entire process, or TCO. So what do we need when we save time? We want an all-in-one system from digital to physical, which means we don't have to convert files from one software to another. We want everything to happen inside an integrated environment. Everything should happen inside the same software. Of course, we want automation to save time, but on the other hand, we still want to have high level of control in order to fine-tune the results of the automatic operations, and so we can optimize it. So for example, we can optimize support structure to reduce the amount of material we're using, and so we're saving money, or optimize print strategies to be as efficient as possible, or optimize machining for post-processing. Another important thing is to have one solution for all the technologies and the machines that I'm using. And we also want to start early. So now with lead times shortening, I often may get the part before it's even finally designed, and I can start working on it. And then as changes come in, I can implement them easily. That will save me a lot of lead time. Right, so let's talk about 3D Expert. It's the all-in-one solution and software solution of choice for industrial AM. Let's see what it holds. So first of all, it was created with production grade in mind. It is for professional users and for serial production, and it takes into account production processes. It was built originally for mixed environments, so it is technology and machine agnostic. It can work on more or less any technology, any machine. It is a single solution for the entire process, which we said is very important for saving time, and as we'll see later, for data integrity. And that includes analysis and simulation tools, which are incorporated inside the product. Also has high level of automation alongside high level of control, which we said is important to save time and to save money. And finally, it does have that design change incorporation, so you can start early, get changes, and then incorporate them. We'll talk about that in a minute. So we have a very short time. I'll try to give you a few bites, and we'll start with what do we mean by a single solution for the entire process. So this really covers everything from importing the data, positioning the data, creating supports, creating lattices and textures and infills, having the build simulation, like simulating the printing, what happens during printing, print strategy optimization, so slicer optimization, tray arrangement with traceability, meaning that you can add labels marking the parts. We even have post-process programming at the highest level inside our software. And we also have printing inspection, which allows you to inspect all the data that you get from the printer about what happened during printing. What that gives you is, first of all, everything happens in the same environment, which means no data conversions. That's very important to maintain data integrity because you don't degrade your data. And also it will reduce costly errors. Now, costly errors, I mean by selecting the wrong file and so on. So a little bit more about data integrity. Right now, it's the only, let's say, professional AM solution that works with BREP. BREP is solids and surfaces. So we can read in native CAD data from SolidWorks, CATIA, NX, Creo, Inventor, anyone, and keep it as solid. So many of the parts we work with are created as solids in these systems. If it's mesh, like it comes from scanning, we can work with mesh, no problem. But if it is BREP, if it is solids, we keep it solid. And that gives you a very high level of integrity. What it also allows for is history-based parametric features, which is this tree of features that you see here that you would recognize from any CAD software that you've worked with, but you don't have that today in most AM software. So that's a great benefit because you can record what you did. You have great traceability, and you can go into a feature that you created yesterday or an hour ago or 2 weeks ago and see what you did and then edit and change it. And as I said, it's a hybrid environment, so you have solid surfaces and mesh working side by side. Okay, design changes. Sorry, we're a little short in time, so I'll just explain quickly. This is the original part. These are supports put on the part. What you see here in red are the changes made to the part, so holes and knobs and slots added. And then with a single click, we just change the geometry to the new geometry and apply everything, all the supports to the new part. All right, so let me give you again a few tastes in a video showing some, like very little of the product. So we start with the support design. We create the regions that require supports. In this case, we start with solid supports. We add fragmentation. We can add a skirt to reduce stress. After we've defined the parameters, we talked about automation. We can save this as a template and use this elsewhere, but we can just say, this is my template, use it in other places, and we use it immediately. We'll see the same done on wall support. You can see there are a lot of types of supports and a lot of parameters, but all of this can be put into templates, and we do provide predefined templates for most materials. But if you want the control, you can see you can go in and modify. And again, once you've defined something, you can use it as is, as a template, or save it as a template and use it later in another file, or use the predefined templates. All right, so that's a quick look at manual supports. Let's look at some more automated support type. So this is our power supports. The idea is you select the part, the system recognizes where are the points that require supports, and then you can define different parameters, which again, you can save as preset parameters, and you just get the support. These are very light support. They're very easy to remove, and this is good for heat sink, not so much for stress. So it's good for parts that are thin or materials that don't generate a lot of stress, like aluminum, for example. So this is, sorry, one type. You can have, we call it the power tower stem, and then you can have the cone stem, which is like a tree structure. But again, the idea is that it's very automatic. You don't need to worry about it too much. You just put in your parameters, select your parts, and then you have your supports. We don't have time to go into that, but there's also a lot of control here, so you can later go on and modify each of these nodes. If they're not in the right place, move them to wherever you want them to be, and so on. All right, lattices. Again, there is a ton of functionality. I took this lattice movie and chopped it, so you'll see a lot of jump cuts, but I didn't speed it up in any way. So this is as fast as it works. You get an immediate preview for whatever you do, and you can modify and change parameters like sizes of the connectors or struts, sizes of each cell, type of cell that you're using, and it all happens very, very quickly. This is a stochastic lattice, so this emulates what happens, the structure that we have inside our bone, and we can control what kind of randomization we want to have there. Again, a lot of parameters. We don't have time to go into everything you can do. You can save them as template and reuse them. This is reproducing or repeating a specific shape. We can have a nice cover if you have an open lattice. So a lot of functions, and finally, I think we'll also see function-based lattice, in this case, a gyroid, which is always very popular and sexy. And now we're jumping to surface lattice or structures. So again, you can use different types of shapes and with multiple layers, and it's all conformal to the shape. The important thing that is important for me to say is that it's all customizable. Other than changing all these numbers and parameters, you can also define your own cell types, your own profile for the struts or connectors, your own shapes for the nodes, and so on. So you have endless control here. And then again, if you want something simple, it comes preloaded with templates you can use. So same as with supports, great automation, great control, as we spoke before. All right. Next up, let's talk about build simulation. So what you see here is the part with marking of the displacement that you will have after the printing in millimeters. And so this is predicting what will happen to the part as we print it, how it will deform based on the actual geometry and supports that it has. And we can show you different things, like we've seen the displacement right now, it's inner and outer. And we can also look at recorder interference. So this will predict if after printing each layer, when the recorder goes by, if it will be hurt by the material rising as it cools down. So this can actually prevent damage to my machine and can show me where I have suspicious layers, and I can go there and check it. And the idea behind the whole thing is to save money. So it can predict when we will have a failed build that will cost us thousands of dollars or tens of thousands of dollars, or in big machine, hundreds of thousands, and then just help us optimize the part so that we don't run into that problem. Right now, we're looking at plasticity that will predict where we're going to have material failures, so tears and cracks in the printing, which means a failed build. So again, the idea is to reduce the amount of tryouts by simulating what happens in the build beforehand. Right now, we are enhancing the deviation so we can see it more clearly, because usually it's fractions of millimeters. So we can make it 10 times bigger and then simulate it or animate it and see the movement from the original part to the deviated part, of course, magnified 10 times in this case. So it's very much exaggerated. There are a lot of other options here. We don't have time to go to all of them. Please, if you're interested, come visit us at the vendor lounge and we'll talk about it. All right, let's look at slicing. I want to pause this just here. Okay.
Another minute, Maoz.
Sure, we're coming. We're very close to the end. So this is the part, and these are the supports. And you can see that the part is, we will see now, the part is sliced every layer and supports every other layer. So that's one way to save time. And you will also see we have concentric slicing here and linear slicing here, but they merge beautifully without any deviation between, any separation between them, sorry. All right, this is just me showing off about slicing for multi-head. So this is a printer with 3 laser heads, and you can see the nice breaking between the layers as we go up and down along this part. Sarah, don't worry, we're at the very end. I think I only have one more thing to show, and it's just for dessert. Okay, yeah, so this is, I said we can program the post-processing, milling and drilling of the part. So in this case, we're milling off lattice structures that was put on this blade to improve stability of the printing. And you can see actually the simulation of the milling of that part. All right, so that's it. Last slide. 3D Expert, software of choice for industrial AM. Remember, trying to save time and money. It's production process oriented, so allows you for optimization, high level of automation and high level of control, keeping data integrity. It's technology and machine agnostic, and most importantly, it's a single solution for the entire process from design to manufacturing. Sarah, I know I'm at the end of my time. Do we have a minute for Q&A?
Yes, we do. And we have after this, so we'll take a couple questions.
Okay.
All right. From Anonymous, how do you view 3D Expert's future on standardization and universality of build preparation software?
So 3D Expert is actually, first of all, we really hope there will be standardization as much as possible. For example, in ScanPass formats that will allow any software to work with any printer. That will help us greatly, but we definitely see ourselves as software for all printers and for all technologies.
Yeah, and I guess kind of a follow-up, how are you working with Dyndrite?
Right now, we're talking to Dyndrite. We don't have a specific collaboration at the moment, but let's see what the future holds in that sense.
We definitely appreciate you being on our developer council.
We appreciate it as well. Do we have time for another question, or
Yes.
are we out of time?
Let's do one from Ivan. How
Okay.
accurate is the prediction of the deformation? Is this prediction part of your software?
Yes. So, I also see another question about how do we perform the simulation, any partnership. So same subject. We joined forces with Additive Works and their product Amphion. It's fully integrated in our software, so we use their engine to do the prediction. So we are definitely counting on them and on the calibration, done with them. And then we just show the results in an integrated way inside our software.